Assalamu alaikum guys. This is Matlab course lecture number 9, part number 2. In this lecture we will solve the second exercise. It is a car crash into a safety bumper. As you see in the image, this is the car, and here it is the bumper system where F equal K V power 3 multiplied by K plus 1 to the power 3, where K is constant. To solve this problem, we have to ask user to enter the mass, we have to ask user to enter the initial velocity, and we have for the K also, ask you to enter the K constant. We will not talk about the theoretical background. We have a solution. For this system, the deceleration or acceleration, negative acceleration, equal to kv power 3 x plus 1 to power 3 divided by m. And the velocity can be solved using dv or dx equal this term. Now, we have to design a Matlab GUI, as you see in the figure here, where we have a list box here, not the pull-down menu like before. It is just list box, okay? So the first option in the list box, it is the plot velocity. Second option, it is plot acceleration. Third option, it is plot velocity and acceleration together. That means the user will decide he wants to plot only velocity or acceleration or both. As I told you, M should be entered by user, K should be entered by user, and V, initial velocity V0, entered by user. And also here, as you see, all of under the constants, we have a gauge. This gauge, it is x span, the distance where the deceleration will be started applying. Say that we want to take or consider the calculation from x from 0 to 6. So we will use a knob. Sorry guys, this is not a gauge, this is knob. Okay, knob to enter data. This is just by mistake. Knob used to enter data, while the gauge, this is the gauge. This one, it's a gauge, not knob. The gauge used to display data. So I think, as I told you, the knobs and the gauges are new in application. You can't find them in the previous GUI, graphical or GUI, graphical user interface or guide designer. This is a new Matlab application version. So as you see, we have some instrumentations here, or tools. Instrumentation tools can be used. One of them, it is the knobs used to enter the data, so that when you select 6, that means the range we want to define a range x span from 0 to 6, so you can change it anytime. Now we have a plot here button. This button guy used to, when you click the plot button, it should calculate everything, calculate the velocity, acceleration, time, everything, and show the final velocity just before car stops. Maybe you can say that if it's a vector or matrix, you can take the last before the last element by 2 or by 3. And here we have an axis where you have, or a plot area to plot velocity or acceleration or both of them. Now, as I told you, we will not go through the theoretical background, how we can solve them. We have the solution, and we want to just solve it using Matlab. How we can do that? At the beginning, I told you we have to go to a new file. You could select script. Surely we are talking about the application. I will not use script or live script. By the way, I will give you a lecture later or recording video about script and live script function, live function. What is the difference between them? You have classes, project, figure, application. See, application, it was before GUI, graphical user interface. Once I select application, application designer will open, and I'm waiting the application designer. As you see, the application designer here, we can start a blank application from scratch. You have here some examples or templates, you can start from them. So I will select the blank application. Once the application designer opened like this, guys, as I told you in the previous exercise or part, what are the main components of the application designer? As you see, we have here at the middle the area or the graph. as you see here, guys, if you look to the right, the name of this graph or this area or this view called app.ui figure. That means we are inside the application. So app small letters dot. The name here it's saved in structured way. So inside the application, here we have user interface figure. Can I change the figure name? Double click on the figure name here, X, Y, Z. But I don't prefer that because no, I will not use the name. So keep it like this, never mind. But surely I can change it. Now this is the view, design view, as you see here. To the left of the design view, we have components, library of components. So we have many components. We have axes here, we have buttons, checkbox, data picker, drop down. We have edit field, numerical numbers, edit field for text, image. We have many things. We have pull down menu, we have text area, we have a grid, layout, panels, menu bar. Okay. We have also instrumentation here. We have, as I told you, we have say knobs and gauges. Gauges to display values, knob to adjust value. So if you want any component, just drag and drop it here. Let me take an example. Let me talk about what is the edit field and what it is the edit field text. Now, guys, I will pick this one, drag and drop here. As you see, this edit field, it is just a space in the design view. Enable the user to enter data. What type of data we expect? We expect edit field. We expect for this one, I choose, I think, I forgot what I chose. Let me go back and I will choose edit field number, numeric. So we are expecting now, guys, that we can use this area to enter numbers, float or integers, all of them doubles in Matlab. So this area, we can enter numbers. If you take the edit field text, this area we can say that show text or edit or enter text. So this say that component can be used to enter data, to show data. It's up to you for numbers. This one can be used to show text or enter text. It's up to you. It depends on what problem you have. Let me delete the second one. Click on the second one, delete. Let me go back to the first one, just an example, guys. When I click the first one, which is edit field, the title here, edit field. Now, let me go to the right corner here, the right side. In the right side, we have components browser. Component browser, where we have the properties for that component. Now, again, I will click here. The component here, as you see, it is app.edit field. Edit field. Now, I know that it is edit field because I selected from left the edit field and it is numeric one. Now, the name of this edit field, you have to ask yourself, do you want to change this name or keep it? It depends. If you want to use the name later in programming or write a code, calculate, plot, it's better to change. As example, in our example here, we have to ask user to enter M. So we can name it M or mass, M capital ASS. It is just a variable name, variable or component name. Click. Now, what is the component name for this one? It is app.mass, not mass. It should be app.mass because it is a structured way or saved in a structure. Now, for this mass component, app.mass, we have many properties like value, the current value is 0. Like the label also. The label, it is edit field. Can I change the label? Yes. It should be, we can write mass. We have to distinguish between, enter. We have to distinguish between the label and titles and the name of the component. Label title is just a property. We can set it, we can get it. Okay, while the name, it should be fixed from the beginning. So app.mass, it is the name. The current label, it is mass. Can I change this property later? Yes. Can I write a program to change it? Yes. What's the current value here? It is 0. Value, it's a property. What are the limits? Minus infinity, comma infinity. They are, it is a property, and this is the current value. As example, the font weight, it's not bold. This is the current value. And so on. So we have many here. As you see, we have here many component properties that we can control them from here in the design view or in the code view. It depends. Now I told you this should be a mass. It's okay, current value equals 0. By the way, guys, I forgot to tell you that we have in this figure, we have two panels, the left panel and the right panel. The left panel to enter data and the right panel to output the data, show the data with some buttons here, okay? How can I bring, say that a panel, go down here. You have panel, drag and drop the panel here, guys. Let me take this text here. We can move it like this. We can resize it like this. Make it larger, make it smaller. If you wish, you can go to here, guys, the top of the file. Click on the grid to show the grid and automatically snap to grid. So it's easier to just jump from one line to another line to resize the panel like this. Okay, now we can, as you see, click on this panel. See, here we have application, user interface figure. Inside we have mass and panel. Now what I will do, guys, I will take the panel, the mass, put it inside the panel. See, now change, the structure change. We have application.UI figure. Inside we have panel. Inside this panel we have mass. Now, guys, this panel, again, what is the name? Is panel. When you copy or drag and drop another panel, it will be panel number 2, panel number 3, and so on. The question is, do we need the name of this panel? It depends. If the name or the panel should be programmed in some way or somehow, yes, change the name to remember what is the name. But in our example, the panel is just background. I will not change it. I will not program it. So keep it like this. Doesn't matter. Now, what is the, as you see, the app.panel title, it is panel. Now, look to the drawing here, the photo. The panel without title, or say that, title, yes. So we can remove it. You can double click on the panel here, title, remove it, or from here. It's up to you. Enter. Now, this panel without title. Okay. Next step, guys. Let me take this one, this mass. It was just an example. I will put here. Now, in this figure, we want to select plot velocity, plot acceleration, plot both of them. So we need to use a list box. In exercise number 1, we use the pull down menu or a menu, the drop down menu. Okay, where the return it's a number. But here we have a list box where a return it is a string. So where is it here? Let me check. Where is this one? It is list box, as you see. Drag and drop here, guys. Okay. Now let us talk about this list box. Again, we can move it from place to place. We can resize it like this. Okay. Now, as you see in this list box, guys, we have option item number 1, number 2, number 3, number 4. 4 options. Can I change them? Before that, ask yourself, for this list box, you want to take the value, the current value, and do something. That means you have to program it. You have to program that or that code regarding that. So in the code, you will use the name of this list box. So I prefer to change the name. If you look to the right, we have in panel number 1, we have mass and list box. I prefer to change it from list box because it could be more than one list box. It will be the name list box 1, 2, 3. You will never know which one for what. So I prefer to say that this is select panel or select. So the name of this component now, again, click on this component. The name of this component, it is app.sCapital_select. Okay, so I can remember that. The name of this panel, list box, it is the select. So I can take a value. Now, again, what is the label? The label, it is list box. I have to change it. If you look to the graph here, the figure, we can say, please select or select. So double click from here or from here, it's up to you. Go to the text here. Change the text to say that select. Okay. Now remember, please, this component, it is app.select. This property, okay, label, it is select. Okay, the label, it is select. So label, it's a property of select. The current value now, see, the current value, it's item number 1 because as you see here, it's say that selected, have been selected. So what are the items? Click here. We have item number 1, item number 2, item number 3, item number 4. We can change them. What items we have or options? Plot velocity. Okay. Next option, plot acceleration. Next option, plot both, as example, plot both. These are the options. Now, what the value corresponding to each one? Here, item data. I will write them here. So, for the plot velocity, we can say that V or 1. Remember that these data, see, data associated with each element of the items, it should be empty array, 1 by n numerical, 1 by n cell. So it could be a number or character. So let us say that if the user selected velocity, it will return 1. If the user selected acceleration, it will return 2. If the user selected both of them, it will return 3. Okay, so you will decide these values. So the current value now will become 1 because, as you see, plot velocity selected. Now this is okay. Now it's ready. Guys, also what we can change here, if you wish. Let me go back to the panel. As you see, the panel selected here. We have background color. We can change the color to, as example, select the colors like this, one of these colors. I will select this color. Regarding here, this one, we can also change the font to be bold, and the background color or the color of the font should be, as example, this one or this one like this. So you can change the property from the component browser or inside the code view by writing some code. It's up to you. Next step, we want the K and V. Same thing, we want K and V. Sometimes it's better to, if you have something here similar, just click Control C, Control V to copy. Control V to copy again. Okay, but remember, we have to change the title or the label and the name. So the second one, it should be K. So click on this one, the name, it's mass_2. Double click K capital as example. The third one, it should be the initial velocity V0. We can say that here V capital O capital. The item name, it is app.vo capital. Now let me go back to here. The label or the text here should be K small, K capital, doesn't matter. They are different from the name. Here also it should be initial velocity. Just how you can show the label here. The initial value 000. Never mind, we have all of them. And we need also, if you look to the graph, we need a knob here, a knob to change the span from say 0 to 1 or 0 to 2 or 0 to 10. So we need a knob. How we can get this knob? We can go to instrumentation here. Where is the knob? This is the knob. Drag and drop here. Okay. As you see, the knob here, title. By the way, let me ask myself, when I change the knob from 0 to 50 as example, or 0 to 1 or 0 to 5, I want to declare a variable from 0 to this value. So I will use the knob name. So it's better to go and change the name directly. So say that X scale, okay? X or as written here, I think it should be X span or span. Let me say that, not X. Say span, okay? So the knob name here, the component name, it is app.span. What are the properties we need? We need to change it from, I'll see on the knob here, from 0 to 10. Select from 0 to 10. So I will go back to this knob and go to the value, current value is 0. Yes, it is 0. And the limit from 0 to 100, keep it from 0 to 10. Enter. So see the limit from 0 to 10. You can also change the size, move it. It's up to you. I will select all of these together, guys. Then I will use the arrowhead to move them up. Okay, so I have the value of mass, K, V0, and the box here and the knob. Okay, next step, guys. Next step. We prepared this design. I didn't program it yet, later on. Now let me prepare the second panel, the output panel. So let me take this panel, Ctrl C, Ctrl V. If I copy this panel, see, the panel and all of the panel components will be copied. So I will delete it. I will go to here and bring another panel. So this is the second panel here, output panel. It should be without title. I'm not aware of its name. I will not use the name for any reason. So just resize it like this. Change the background color. So let me go to the background color here, change it to, say that, this color as example. Now as you see, we have here, we have application, inside we have panel and panel number 2. I'm not aware about the names. I will not use them. Next step, we need the axis here. Okay, where is the axis? Let me go to the first one, axis. Drag and drop like this. Okay. Regarding the axis, guys, the title is title here. As you see, what is this axis? Before that, ask yourself again, you want to use the axis name to program it? Yes. In this case, you have to name it. Let me name it my plot, or say that plot. By the way, this plot is not a function name, it is component name. Okay, just to remind yourself that the axis name is plot. Now I will click on the plot again. Again, the title is title. We can change the title in the code view by writing some code, or design view. It's up to you. I will keep it. Okay, for example, I will keep it in the code. I will show you how you can change some properties, text properties from the code. And label it's X, Y, keep it like this, okay? But let me say that, go to here. Just to remind you, we have some properties called, forget this one, forget the labels. We have text, we have ruler. You can change the X limit. See, the X limit, it's auto mode, and Y, it is auto. So we have a grid here. We can show the grid in X direction, in Y direction, and Z direction. And you can change the grid color. As example, grid color, it should be red, and minor, you can change what you want. We have here also multiple plots if you want. We have many properties. We can change them in the design view or the code view. Okay, next we need this knob, this gauge to measure or to show the velocity before just the car stops. So we have to go to the instrumentation here and select the gauge. Gauge, it is a component, instrument component that can be used to show something. As you see, the gauge here is from 0 to 2. Click on the gauge. Okay. As you see here, the limit, it is from 0 to 100. Make it to 2, 0 to 2. And it's very important to ask yourself again, this gauge, it should be programmed, or during the program you have to know what's the name. Yes. So name it here V end, V end. Okay. The velocity at the end, V end. And the title here, as you see in the graph, speed just before rest. We can change the title from here or from here. It's up to you. Speed just before rest. Okay. Can I change the color? Yes. Double click here. See, we need the background color. Yes, here it is a background color. It's white. Now we can change it to say that green, and you can select this color like this if you wish. You want to change the text, say that font color, we can say that this is like this. You want it bold, italic, whatever. Okay, you can change it from the design view or from the code view. It's up to you. Next, guys, we want the plot button. We have to go to here and bring a button. a push button here, guys. It's okay. Let me move it, this one to the left a little bit, and this button you can change the color. Now, guys, regarding the button, I'm not aware of its name. I will not go somewhere and take the name of the button. No, I want to activate something when I push the button, so I will program it. So no need to take care about the name. It's button. Keep it like this. Never mind. But the title, the text of the button, it should be plot as example. Okay, don't say that, or we have to distinguish between say that component name plot, as you see it is app plot, and here as you see it is plot also, but it is a text property of another component, so don't mix them. Okay, so again as you see here we have component library, we have just drag and drop here we have component browser with properties, and here you can navigate between the design view and code view. And here we have a run. Here we can show the grid and snap and so on. Now, guys, if I run the program, I will show you. Run the program. First of all, we have to name it. Say that example or anything. Okay. I'll see this is the application. Matlab application user interface. Okay. See, you can select any one of them. You can change the knob from 0 to 5, from 0 to 9. You can press on this button. Nothing happened because not programmed yet. Now, as you saw in the run example, if you click on the plot, nothing happened because we didn't prepare the solution or the code yet. So where we have to write the code, it depends on some action. What this action? Clicking on the plot. So what I will do, guys, I will click on the plot here, right click. By the way, you can copy, if you select it like this, you can copy, paste, duplicate, delete, callback, help. You can get help on that one, by the way. If I select the help, the Matlab will give me the help text about the button, how you can see, how you can use the button, what are the components, properties, and so on. Again, right click, callback. Callback, guys, see, add a button pushed function callback. It will create a function for that button. See, guys, this is the function in line number 29. Just enter. Here we have to write our code. Now again, just to remind you what I'm trying to do, I'm trying to find the solution of this equation where it is dv over dx equal this term. You remember how we solved the differential equations ODE in lecture number 7, I think, or lecture number 8, I think, okay? We will solve it here, same. So how we can solve? First of all, we need, as you see, we need the value of k, we need the value of m, and we need also to define the ODE and find the solution. So let us start. How we can, let me take it a little bit to the left. Okay. Now, guys, we want to get the value of this area. Okay, so where is in the design view, as you see, we want to get this value. Now, what this name, component name, it is app.mass. Which value we want to take, which property? The property of the value. So we have to take it in the code, go back to here, say that m small for mass, it's just a local variable. By the way, m here, guys, it is a local variable, belongs to this function. So accessible from this function. We can't use it anywhere else. If you want to use it, you have to define it as a global, or you can go to property here, make it public property. Anyway, so m equal, I will go to app dot, which one? The mass. Once you wrote m, you have component names here. Say mass dot the property. Which property? It's a value. Write v. You will see the properties you can select. I will select the value like this. I will do the same thing for k and same thing for initial velocity. So we need also here 1, 2. We need also the k value, give it a name, say k small, it's just a variable name, local variable belong to this function, not component, variable. the component, we have to go to which component. I think the name of the second component, K here, click just to be sure it's K capital, as you see. Let me go back to the code view. Again, this should be K capital. As you see, it gives us components. I will select K capital. For the last one, it should be, I think, V0. Let me name it V small, 0 small, O small, sorry. And the name, it is V0, I think. VO or V0, VO, I think. Let me check again. Go to design view, click the third one, go to here. It is V capital, O capital. So as you see, good. So I will take the values. So the first value assigned to M, second value assigned to K, third value assigned to V0. Remember that mass, app.mass, app.k, app.v, it is a text edit field, numerical one. So the value here, guys, it is a number. If it is at a string and you want to change it to number, you can say that str to num function like this. But no need, because we know that it is a number. Next, we want to also to know what is the option selected by user. Is it the first option or second or third option? So let us say that choice, it is ch or whatever, anything, ch as a variable name, not a component. The ch, it should be the value of this one. Let me go to design view, click on this one. See, what is the component name? It is app.select s capital. Which property you want to take the value? Okay, let me go back to here. Say that ch equal app.se. I have here select value like this. Okay. Later, next step. So we have K, we have M, we have V0, and the ch, the option selected by user. Now it depends on the user selection, what we should do. Before that, guys, let us solve the problem. Find the velocity value and a value according to the span from 0 to x. So let me bring also the span, or get the span. Say that the span is s equal, it's just a variable name, s small, never mind. Okay, it's a variable name, local variable, okay, not global variable. S equal, I will go to app.span, I think, the name of this component here. Let me go back to design view and click on the knob, okay, here, and this knob name, it is span. By the way, we forgot to change the title of the knob or text. Let me say that x span as written in the graph. Okay, so again, the name of this, it is a span. The name of this knob, it is app.span. Let me go back to code again. S equal app.span. Yes, span, we have it. Yes, we have it here. Value. The span, it is number. It is a number value, numeric value. Okay. So we have the span now. Let us declare the x. X equals, say that from 0 to the span, which is s. Now you have to indicate, semicolon, you have to indicate what is the increment. Say that the increment, it is 0.1 as example. Never mind. Next, guys, how we can solve this ODE, if you remember, we have to say that sims, we have symbolic equation, system of what? Here, here we have, as you see, v function of x, So we can write v of x like this. Okay. Now we have to say that the ODE equal what? Equal dv, which is differential, the derivative of v, okay? Derivative of v for x, which order? First, second, third. It is first order, so you can write one like this. Okay. Double equal, it is equal to what? Equal to minus k, to minus bracket. We have k here. K. Remember that. What's the value of k here? It is assigned to this k. So I will write k here. Multiply by v to the power 3. V, it is this v. It is symbolic variable. So v to the power 3. And here, guys, to the power 3. And here v, it could be vector, matrix, whatever. So we should take care about it. Dot, element by element. and then this one multiply by this one multiply by x plus 1 to the power 3. So x plus 1 to the power 3. To the power 3, same thing, to the power 3 here. Okay, same thing, element by element, say dot. And finally divided by m. And finally divided by m. So let me take brackets like this better. Okay, and divided by m. And same thing, division here, because we have vectors, say that element by element better. Just take care about different options. Now this is the ODE. How we can solve it? If you remember how we can solve it, we have to write the solution as the following. We can say that solution equal desolve, if you remember, desolve what? Desolve the ODE. If you have a condition, write condition 1, condition 2, condition number 3. Now guys, the initial condition here, it is just that we know that the speed when x equal to 0, it is v initial, v0, kilometer per hour. So we have to say that, we have to define the condition, say that cond equal, condition here equal to, say that to v0. Remember that the v0 value assigned to vo small variable, so vo. And it should be converted, I think, from kilometer per hour to meter per second better. So let us multiply it by, to convert by 1000 divided by 3600, like this. Better to convert from kilometer per hour to meter per second. So we know the condition now, we have the ODE, we have the solution. We have the solution. It says that here the value assigned to variable SOL might be unused. Never mind. Now we have the solution. Actually, the solution represents what? The solution represents the V. Don't forget that. Represent the velocity. The velocity. And it could be matrix or vector, depends on the solution. It could be one solution or two. By the way, here, because x here to the power 3, we expect 3 solutions sometimes. It depends. So now we want, we have the solution of this ODE. We want to plot the solution. And the plot, it depends on what? The user selection. He wants to plot the velocity or acceleration, or velocity and acceleration. So let us define the acceleration first. Say that A equal, as you see in the equation here, it is minus k again. Remember that k assigned to this k variable, minus, we can say that minus k multiplied by v to the power 3, v to the power 3. And better to write dot here, and this multiply by x plus 1, all of them to the power of 3 again, and make brackets like this better. Also divided by m, like this, and this should be dot here, and I prefer to put dot here also. And now, what is the value of v here? Remember that it is the solution. We found the solution. So I prefer to write solution here, SOL. Okay? Like this. So we know the value of the acceleration now. If the ODE solved, the solution which represent the velocity will be inside the SOL. When you take the SOL as velocity, apply in the equation, you will get the acceleration. Next step, to plot. Okay, so the plot, guys, now it depends the user selection. It depends on the value of CH. If the value of CH is 1, we want to plot the velocity. So we have to use switch or F. It's up to you. Let us say that switch. I want to switch on the value of CH. This is the end of the switch. We have case, say that the value equal to 1, I will do the following. I will plot. To plot, guys, here we have to write, we have to write the, say that the plot, say that the handler name of the axis, what the axis name, if you remember, it's app plot. I'm not sure, go to design view, select the axis, this one, and see app plot. So we have to go to code, say that I want to plot on this one app.plot, comma, I want to plot what? I want to plot as example x in x-axis and the solution in y-axis. And we can say that I want to plot it in red color. And we can say that the property line width outside comma, it is 2. And regarding the second case, I will repeat the same thing, Control C, Control V. In case that the value it is equal to 2, not 1, because the value should be 2 for the next option. I want to plot same x, but with acceleration, which is A. Say that it should be red, keep it red, never mind. Line width 2, it's okay. And the last case, we can say that otherwise, or you can say case equal to 3, it's up to you, both of them works. Otherwise, it should be both of them. So let me copy both of them like this, Control C, Control V, and remove this case. As you see, we have the first plot. To plot in one figure, guys, we have to hold. By the way, hold on. Can I use subplot? I can use subplot here, no problem. Hold on, hold the plot. This is in Matlab Script, but in say that in Matlab application, because we have a handler here, no need for the hold on, because the handler will tell us where we have to plot, so it will be enough. But let me change this one to blue, okay, and surely we can. Now, I told you regarding the axis, let me go back to design view. I told you regarding the axis, we can change the title labels from here. Also, I can use it in the code. I will write in the code, I will write, guys, the following. Say that title, it's a function. Which figure? It's app.plot. This one, okay, comma. It should be what as example? It should be velocity or acceleration, or and velocity and velocity, or better, or sorry, both of them together, velocity and acceleration. Okay, like this. Regarding the x label, same thing. X label, it's a built-in function for which plot it is app.plot. What is the label? It should be here. In x direction, it is distance. We can put brackets like this, x. And regarding y label, same, it's a built-in function for the app.plot, and the value of the label in y direction, it is velocity or acceleration, it depends. And surely, because we have two graphs here in one plot, or two plots in one graph, sorry, we have to say legend. Same thing, legend. Can I change it from the design view? Yes, but I will write the code. It's for app.plot. The first plot, it should be velocity, comma, sorry, outside, comma. The second plot, it should be acceleration, like this. So I prepared everything. It gives us here some warning, not problem or click here, specify UI axis handle as a first argument. It's already specified. Because I forgot to, this should be capital letter, I'm sorry for that. This should be capital letter, so it's okay. What about this one? Specify UX handle, yes, this one, it's also P capital. Same thing here, P capital. What about this one? P capital also. All of them, I forgot. I think, I don't know. I selected P capital, but never mind. Okay, save. So now, in case that the user select 1, the first option, it will return 1. If it's 1, do the following. If it's 2, do the following. Otherwise, do the following. Can I repeat this one also? Title X label for each plot? Yes, we have to do. Control C, go to plot number 1, Control V. But here we have just velocity, not acceleration for the first one. Distance in X axis, Y axis, it is just velocity. Legend, no need for legend because just one plot. For the second one, same thing. Let me repeat this one. Title label, Control C, Control V here. The title should be acceleration. In X-axis distance, in Y-axis it should be acceleration like this. I have no need for legend. I prepared the graph. Now everything programmed. But last thing, guys, we have to display the velocity just before the rest. If we take it exactly the last element in the solution, by the way, solution here, it will be array or vector. If you took the last element, it will be 0 because rest. But let me take it before as example, before just the rest by 3 items or 4 items, doesn't matter. So how we can do that? After this case, we can say that I equal to 4. Or sorry, length. Let us bring the length of the solution. Length of the solution. It depends on the solution length. So let us say that we want to show, say that as example, say y equal solution of the last element, which is what? Which is the I, or say that, let me say that length, L, better. L equal length of SOL. I will say that the solution of L minus 4. That means before the end by 4 elements, give me the velocity. Approximately this is before the rest. But now, which y? We have to show it in this, say that this gauge. What the name of this gauge? Let me go to the design view. In the design view, click here. The gauge name, it is app.vend. app.vend. So the current value, it is 0. We have to change it to what? To what we found. So here we can say that app.vend, which property? The value of property equal to the solution, which element? L minus 4, index with L minus 4. So I think the solution now, it's okay. I have all of the components, as you see. Again, M, we got the value of M, we got the value of K, we got the value of V0, the selection of the user, and the span from the knob. We defined the X vector from 0 to S, the span given by user. We defined the ODE and we solve it. The solution, which represents the velocity, will be SOL, and we calculated the acceleration and we plotted everything here. Now I don't know, is it okay or not? Let me save my graphical user interface application 1 and let me run. You can run from the code view or design view, both. Now regarding a figure, it's okay, we have everything. Now let me put the mass as example 1500, the K value say that 30, and initial velocity say 90 as example, and say that the span from 0 to 6 as in the example here. And let me take the figure to the right, and let me show also the MATLAB say that workspace and the MATLAB command window, because anything will be reflected here. By the way, all of the local variables in the application will not shown in workspace, but I will teach you how, if you have an error, how we can fix it. Now I will plot. Just click on the plot and wait. Nothing happened yet. Why nothing happened yet? We don't have mistakes. Let me go back to the application designer. Maybe we have some errors here. I don't have any error. Yes, we have an error here, guys. Error using value invalid equation here. SOL equal D, solve the ODE condition. Why we have a mistake here? I think here there is a mistake here. Condition it's equal to if you remember, it should be v of 0 like this, equal to v0 multiplied by 100 by 1000 divided by 3060. I think this is the mistake. Let us try again, run the program and wait. Again, this one 1500, say k30, say velocity 90, and we have from 0 to 6, plot and wait what will be the result. We have another mistake here. That means the ODE solved correctly. Here we have in the plot, error using plot, data must be numeric. Okay, data must be numeric. What meant by that? Okay, SOL. So I know why, because SOL here, guys, SOL here, it is the solution, and the solution here it will be in a form of symbolic equation. If we my advice in this case, before solving using the ODE in the application, let me do the following just to show you what I'm talking about. Let me go to X from line number 34 to here. I will copy them. I will go to Matlab Script. I will open new Matlab Script. I prefer this option before put the solution in the application, Matlab application. So CLC clear like this, and let us run the code, save it, say .m, run the code like this. Let us see, we have a problem, same problem. Undefined function or variable s, yes, because s here, let us say that s, it is just 6, because we have to take, and we have to define, let us define the value of k also. Say k equal 30, say the mass m equal to 1500, and say that v0, initial velocity, equal to 90, because all of these will be entered by user in the APP, but here we have to define them. Now run the program again. Good, the solution is correct. We don't have a mistake, but look, we have the SOL. See, the SOL, it is one by one symbolic equation. If you go to here, see the solution here, it is a number, yes, but written as a symbolic equation. So how we can change it from say that symbolic equation to a number? Just write double, a built-in function. It will convert this one to double. That's it. I will show you the difference now. Save, run the program. We have another problem, but see, if we change the solution to double, it works for the solution. No, not work. We have a problem here. Unable to convert expression into double array. We have problem. What this problem? Again, code, condition, solution equal double, desolve. Okay, I prefer not this one, this option. Let me check the following. Let me say that we have a velocity v, say that vv as example, equal double of the SOL, and let me check. Save, run again. Same problem, unable to convert into double array. So where is the error here? I think, yes, I forgot something. We can write here the solution of x equal to desolve ODE condition. Say that yes, here we have to say that VV equal double. Before that, we have to say that VV equal to subs, because the solution will be equation, subs the solution for each x, and the x value, by the way, we have to define it. We have to define it here. not before. We have to define it here. We can say that this is the value of x, VV equals subs of the solution for each x, then change the VV from sims to double. We can write VV like this, and then calculate the acceleration. Acceleration equal to what? To the VV like this. Let me run and check again. Yes, but the solution here, it as a sim, we have it. Multiplication. Where is this multiplication? In line number 14. In line number 14, it's dot to the power 3 times x dot. I think here should be also dot star. Run the program again. Yes, I'll see VV. It is a symbolic equation here, but it should be converted to double. As you see, where is VV? VV, it is 1 by 61 double. Okay, no need to, or keep it like this, never mind. So we have the VV for each x. We have the VV for each x. As you see, x, we have 1 by 61 double. For velocity, we have 1 by 61 double. Regarding acceleration, also we have 1 by 61 double. So now we can plot, just to be sure. This is plot. I will put them both in one axis. Say x VV, x acceleration like this, and run the program. Yes, this is the plot, which is correct. So my code is correct now. Now we can take the same code, remove the plot. No need for the plot. Just take the same code and change something. Let me go back to the say that the code view or the application. Where is it? Where is the application? I forgot. Oh, well, I forgot. Maybe this one. I think this one closed by mistake. Yes, this one. Let me go to code view, and let us go to here. Where is the solution? From here. I will remove all of these and paste the previous code. But double check. ODE equal, it's okay. Condition V of 0 equal V of 0. That's right. Equal V0. Where is the V0? This one. Solution of x equal dissolve ODE condition. X equal from 0 to not 6. It should be the span. The span, it is S. Okay. VV equals subs of solution for each x, semicolon. And VV equal double of VV to convert it to double. Now A, we have everything. Okay, now let me run the application and see what will happen. Okay, so now it will be 1530 V0 90, and say that from 0 to 5 plot. Remember that the first option selected velocity only. Do we have an errors? I don't think so. We have an errors. Yes, error must plot. So on the otherwise, data must be numerical one. Plot x with solution. Yes, we forgot. We have to plot x with VV. So here we have to change it to VV, and here we have to change it to VV like this. Very good. Run again. And wait, let me minimize this one. Okay, and this is the application, and let me write here CLC to see if there is a problem. Here it should be 1500, here it should be 30, and here it should be 90 as example. Take it from 0 to 7 or 0 to 6. Anyway, plot. Let us see what will happen. We have another problem here. The length for the input. Where is the length here? Argument of type sim function. Where is it here? Length. L equal length of solution. It should be VV again. Never mind. It's okay. Save. Run again. Just I want to show you that there is nothing here in the workspace. come from the application. This is the old one. Again, this is 1500, this is 30, and this is 90 or 92, doesn't matter. Okay, this is from 1 to 6, blot and wait. I think this is the last error. We will see the figure now. Same, L equal length of VV, undefined function length. Oh, the function itself wrong, TH. Okay, never mind, let me go back to, no need to run again. You can see now, but the velocity not displayed. Let me plot again. Okay, I will close it. Error here also. What this error? Value must be finite numeric, such as 10. So we don't know exactly what happened here. It should be a value because, yes, it's solution. It should be VV, because we change the matrix now, or the vector, it's VV. Now it is the last error. We have to see a full solution now, complete solution, correct solution. So again, sorry for that, 1500, 30, V0, 90, and the span from 0 to 7 as example. Plot, we will see everything now, inshallah. We got a warning, just a warning. It's okay. See, this is velocity. We don't have legend, I think. We wrote legend in the graph number 1. We don't have legend. That means there is something wrong in the switch statement. Let me select the second one, plot. We'll get the same. See, we have a problem. Plot both. We have a problem. I don't know what this problem. Let me show you how we can fix this problem. Actually, I know what's exactly the problem, but let me show you how we can discover that. I will close this one, no need. I will clear the workspace. CLC, nothing here, that's okay. Now, nothing in the workspace. If I run the application, I will never see the workspace, the application local variables here. So to do that, to show the local variables, let me check to here. Okay, I will put this mark like this. Then I will run. It will not run the complete application. It will run step by step. I will show you how. Right, this is 1500. This is 30 as example. This is 90 as example. The span from 0 to 10 as example. I will select any one. Plot. I will select the second one. See, I selected the second option. Plot and wait. Extra legend here. Never mind. What's wrong with this one? Never mind. I can't see anything here. That means nothing wrong. Okay. Let me put it. Let me stop. It's already stopped. Let me put it not here. I want to see. Say that here. Okay. Oh, now it comes. Never mind. See, guys, A equal 1 by 1 double. It's correct. X 1 by 1 double. V 1 by 1 double. V0 it's 90. It's okay. V it is 1 by 1 solution. S span. Okay. But the problem, see, the problem it is CH. It is 2 as a string. See the CH. It is 2 as a string. This is why we saw just the first plot. See, because the value retained by the CH or by the list as a string. So let us convert this string to say that to number. How can I do that? Before, see, take the CH equal app.select value here. Say that I want to convert it from str to right here like this. You will see some functions. Let me repeat it again. Str to, see, str to function, str to double. Okay, just to convert this string to double, because the 1 and 2 it should be a number. Okay, or we can change. By the way, you can use this one, or we can do this one, or keep it as a string and write it here as like this. Both of options will work. Let me keep it like this. I will remove this one. I will remove this one. Then I will change this as a character or string. Sorry, this as a string. Otherwise, like this. I think now it will work. Now it should work. Let me quit debugging now. Okay, save my modification. Run the application again. This is 1500, this is 30, this is 90. I will select the second option to be sure that it works, and the span from 0 to 10, plot and wait. I should see the acceleration here, not the velocity. What's wrong till now? I don't know. It should work. Never mind. Yes. The mark it's still there. I'm sorry for that. We have to stop, quit debugging, and remove the marks. Remove the marks, then run again. I'm sorry for that again. It's good to learn from our mistakes. Always the mistakes give us some experience. So I know these errors before, but sometimes I forgot. Okay, so this is from 0 to 10, plot again and wait. Again, we have to see the acceleration because I select the second one, and we discovered that when you use this checkbox or list box, the return it is as a text. We have to convert it to double or use it as a string. See, now it is correct acceleration. Now I will go to plot velocity. I will plot velocity and wait. By the way, see here the velocity just before rest, it is around 0.2. This is the velocity. We want both of them. Plot. You have to see both of them now. We have a warning. Yes, we can see just velocity. I don't know why for both we are seeing just velocity. Maybe the axis, maybe you have a mistake here. No, otherwise it is VVA. It's okay. It's okay. I think it's working, but we have a problem in the axis. Problem in the axis. So let me change the span. X span. Still working. Why? Yes, it is say that 3 span to 3. Plot and see what will happen. Takes time because we have matrices. If you remember, we have 100 by 100, 100 by 1 elements. Still now it changed a little bit, but we can see just the velocity, not the acceleration. But here, see the title, it's velocity and acceleration. That means it working well, but the plot of acceleration, it should be like this, not coming, because we have to change the axis and control the axis of this plot axis component. So anyway, it works. As you see, the velocity now, the velocity just before the rest, it is around 0.7. So as you see, this is complete exercise, show you everything. But let me show you again. Let me tell you something again. Show you again how we can say that, how we can find the mistake if there is no indication about where is the mistake. I'm trying to close it. Okay. Again, I told you, here is the callback. You just put, say that I want to know until here what are the local variables values. Then run. See, it will run until line number 54. I will select the second one. Okay, I will put the values, say 550, 555, say that 50, this is 10, or say that this is 85, and this is from 0 to 4. Okay, plot and wait. Should not take this time, but let us wait and see what happened. It will run the code line by line and give us opportunity to continue line by line also. So each line executed, it will show you the workspace variables here. Now it's okay, the drawing or the plot is coming. Okay, let me, oh, I think we have to run from here. No, it's same. It's same. I don't know why it takes time, too much time to do that. Should not take this time. Plot again. Let me put another one here also, and plot again. I don't know why it's take this time and not showing the local variables here. But anyway, this is the way how we can show all of the local variables here, so we can discover what are the returned value, how we can fix our program, and so on. So it's supposed that we see all of the local variables here now. I don't know why. Maybe I should close it like this. Okay. Anyway, this is the way how we can fix it. Thank you so much in watching this video, and see you in next video inshallah.